G'day, this is Marcus from LittleBird and welcome to the first episode of the LittleBird Show. Today we're going to have a chat with Simon Blyth from LX Group about his new IOT core. So let's check it out. When did you guys actually start LX?
I think it's 9 years, 3/4. I think we're coming up to 10 years. Yeah,
Wow.
That's a while now.
Yeah, pretty much the same time we started LittleBird.
Yeah.
Pretty funny. Okay, awesome. And were you always out of the ATP?
No, so started in Barara.
Yep.
So like literally out of the garage kind of thing. It was just me. And then ATP was the second year. So went in there by myself and our first intern joined in. So.
Oh, awesome. And so how did you go about getting interns?
Well, Sam.
Sam.
First intern.
Sam's your first intern.
Actually approached us. So I had a little ad in the Yellow Pages, and the Yellow Pages ad, like the sales rep was really good. So we spent, anyway. But he just found us there. He was trying to find an internship, and I said, listen, you've got to understand, it's just one person. There's no one else here. And he said, well, I kind of need an internship, so.
So to complete his studies.
Yeah, totally. Yeah. So that was our first.
Yeah, first hire, and he's still with the company.
Now he's running a show. So yeah.
That's pretty cool. Okay, and you started that just by yourself, or with your wife, or?
Well, so Kel and I. So my wife is a double E as well, and a remarkably good one. We did our thesis together at uni.
Yep.
Actually, in ultra low power, Zigbee kind of stuff, and she went to work for Resmed for a couple of years. So I kicked it off, and then a couple of years later, she was looking for a change, and I was needing someone, and we kind of looked at each other and said, "We're really going to do this," and you would understand too with a little bit. And you know what? It was brilliant, really brilliant. People say, "How do you work together?" And it's kind of like it just when you're running a company together. Makes everything easy. So just doing the washing up is like a pretty simple question to answer. Right?
Yeah, the communication bandwidth.
Yeah, like you've got systems and processes for everything, so everything else becomes easier.
Yeah. Okay. And so now, how big are you?
So we're now around 25 people. It's around 30 people if you look at individuals who are involved in the business, but around 24 or 25 FTE.
Okay, I should probably ask, what do you guys do?
We're just a bunch of nerds who love building stuff. So good nerds, right? Like, So we're a team of hardware, firmware, and software guys who are engaged often on a contract consultancy kind of basis to build products for other people. So our clients typically range from startups, technology entrepreneurs who don't have an engineering team, through to multinationals who are, they've got their own team, but they either need a specialist skill set or they just have too much stuff going on and they need to outsource some stuff. And we've done work for defense, and we've done work for a lot of different organizations. I mean, it's over 200 IoT products now.
Right, just IoT.
Just IoT. And that was kind of a natural thing because we started off in ultra low power wireless. That's Internet of Things really. And over 350, even 400 products and projects overall. Right?
Wow.
So,
wow.
But a big percentage of that has been IoT.
Okay.
But yeah, we build electronic products for other people. We don't do the industrial design. We've got a really good team who do that.
This is how we're actually doing this from a real business.
So we don't do the enclosure design. That's a partner company.
Yep.
But we do everything else. We do the hardware, firmware, software, the cloud backend, and that our app journey has been interesting, but we're getting there.
Okay. So what's the craziest thing you guys have built?
We've built so many crazy things, like really from stuff for Black Hawk helicopters through to Fitbit for cows to tell you when they're on heat, right? So to know when your cow is on heat, so you can take appropriate action. So I think that's one of the things that I and the rest of the team love about Alex is that you don't know what's coming through the door. We've worked on the EEG headset kind of stuff for Motive, and we've done some remarkably odd things as well as some really cool stuff. So one of the coolest things we've worked on just recently has been like this wearable stuff that's a highly intelligent kind of wearable device. doing some very, very cool things, as well as like a device at the moment that's got like an A9 processor down there. It's really the same level of complexity as an iPhone motherboard.
Wow.
So for me, that's really, it's a really big step to kind of, you're building a team slowly, but you're getting to the point now where you can look at it and say, the iPhone, we could do something like that now if we want.
Certainly from the electronic standpoint.
Yeah.
Softwares.
Yeah, so right. I totally agree with that. Yeah, I mean, I'm talking hardware. So we did a board that was kind of at level complexity recently, and it came up the first time. And we're like, wow, we've been really working on checking procedures. It wasn't so long ago that we kind of, getting connectors around the wrong way. And
yeah.
But anyway, yeah.
So what are the tools that you guys are using on a day-to-day basis these days?
Yeah, Altium Design is our
You go to?
Yeah, totally. So we're Altium guys for hardware. For processors, we've worked with over 10 or probably even 15 different processors from Microchip and TI and Atmel.
Mm-hmm.
But we're really starting to standardize on the STM32 range.
Yep.
And that's some of the stuff with our new stuff where we're settling there. They're a lot of the stuff we do is commercial high grade stuff, so it's really what we're looking at now. Yeah,
business is good. So why the STM32?
It's a really we love the Cortex architecture, right?
Mm-hmm.
And ST, whenever we've worked on some really high volume products, like in the millions. For example, if you're making a CPAP for, say, ResMed,
yep.
You find that when you get down to it, the STM32 it has all the grunt you need, it has a lot of the ultra low power stuff you need, but it's often at a price point that ends up meaning it can go into a really, really high volume device. So we want to, because some of our projects, some people don't care about price point, and some people really do.
Yep.
So you kind of want to have a platform that's like, it doesn't matter, that the price is going to get to the right point. But it's really high quality stuff, so it's the kind of stuff that goes into mission critical applications, right? Like it's, ST are really some of the really mission critical stuff you often find an ST part in there.
Okay.
But we don't, we work with so many different processes, it doesn't really matter, but that's
what you're focusing on.
Yeah.
So in terms of platforms, IoT land, what are you guys using there? Like there's IMP, there's...
Yeah, so we've worked with a lot of them.
Yep.
We've worked with IMP, we've worked with a whole, probably, I would say that when we look at an IoT project come in, there have been times when we've spent literally weeks getting dev kits and evaluating things and seeing what we should use for that particular project. And what we found is we're bouncing around a lot between platforms and, in terms of hardware and firmware and cloud. But we're doing these big scans to see what would be appropriate, and we're finding that a lot of things aren't quite right for what we needed. Right? It was because of either power consumption, or it was because of size, or it was because of flexibility, how much it could do, how much grunt it had, although you often don't need much grunt for IT. And we just found that when we're doing projects, you want to do something that, you want to try and standardize a little bit on one thing.
Yep.
And that's where what we started to do was say, well, listen, all these projects are the same. Like that, to the client, they're really, really different. Like, it's a cow device as opposed to something for aviation, or as opposed to something for, marine or whatever. But at the end of the day, for an engineer, like, it's just the same stuff. You've got a power supply,
yep.
You've got a processor, you've got some connectivity, you've got some sensors, and on occasion you might have an actuator. And for IoT, often your user interface is like, a couple of LEDs and a button.
Yep.
I mean, sometimes you go with a really nice, slick, totally. But often that's all it is. So what we did is we just looked at those common configurations. We actually analysed literally hundreds of different use cases, from a dog tracker through to a base station for LoRa or whatever it might be. And we came down to these common requirements that we crystallized into not one, I'm going to sound like not one, but we couldn't do it in one. We could do it in 3 different IoT cores.
Yep.
So what we've done is we've looked at the different permutations of things will crystallize into one bit, well, 3 bits of hardware.
Okay. And for the back-end cloudiness,
Yeah.
how are you using that?
My favorite, so I'm more of a hardware guy. But we have some really good firmware and software guys. So we're using the Microsoft Azure IoT stuff. We're writing in the process of writing a little IT kind of operating system on top of FreeRTOS.
Yep.
Right, in devices. And then really we've got a bit of a cloud solution that we've built up over time for the Koala project and a lot of those things. And so we've got something now, but the visualization is the stuff that we're looking to partner with. So like Freeboard, just to kind of drag and drop some graphical widgets, is what we're doing for the actual, if you just want to put a temperature sensor out there and just be able to map the temperature, you can drag that in. Or if it's a location like GPS, you can just kind of pull in a graphical widget and get location. And then of course an API, so people can, develop their own software on top of it.
Okay. Have you guys played around with the Amazon IoT?
Yeah,
we
have.
That just came out.
Yeah. So we're working with probably a year or two. We're looking at the Amazon stuff a lot. And listen, our main software guy is a big kind of Microsoft guy. So I think probably that's one of the things that's funny.
That sets the tone.
I know. Sorry, I know.
No.
Do you want me to leave now?
It can't be all part of Steve's chosen race. Awesome. So, what's the work that you're most proud of?
I'd say, the platform we're working on probably is really what I'm most, because for us as a company, we're for 10 years we've been consultants, contractors, and now we're doing some stuff that is new and innovative and it's out. So probably I would say this.
What's this?
It has an internal code name of Zangor, right?
Zangor.
You can blame Keith for that one.
Okay.
We don't know what to call it yet, but at the moment we're just calling it the LX IoT cores.
LX IoT cores.
Yeah, we really got to work on a name, but at the moment that's what we're
This is being marketed. I've been around the internet.
I know it's been, because we had a bunch of fights internally, not fights, but like arguments like this. There's whole things like Sugar Cube and bloody Nox rockets and like you know what it's like to name something. It's not easy, right?
Ninjas.
Yeah, but Ninja is good. Yeah, really.
Yeah. Well. Okay, so show us the LX IoT core.
So this is the big one. This is the burger with the works. There are 2 others that are not yet produced, but we're working on those now. We're just waiting for them to come in. You can kind of call this the base station core, but it's kind of funny because it can also be a dog tracking collar. But the 2 other ones, there's a sensor core that's smaller again. It's about 16.5 mils wide, and then a wearables core, which is about 12.5 mils wide.
Right. If you want to show us what's on it.
Yeah. So this right here has 3G.
Yep.
And if I flip it over, that blank spot there is where your SIM card goes. That's for an embedded SIM.
All right.
You've got another SIM card up the top here for applications that need dual SIM, or if you want an application where you can take it in and out, because when you put in an embedded SIM, you're locked in.
Okay. Dual SIM applications.
Yeah. So dual SIM sometimes kicks in when you've got mainly for the logistics. So if you're tracking a truck across a country, sometimes you actually want to straddle between 2 providers to get better coverage.
Yeah, that makes sense.
But probably the first thing I want to point out is that this looks really long, right? It looks like a really long board, and it kind of is. It's actually the length of a credit card.
Right.
Yeah, it's spot on. We didn't mean to do that, but we put it in front of a credit card. It's exactly the same length. But this is not what I think of as the core. When I think of the core, I actually...
You can come around and...
Yeah, if you kind of cut it off here, and you cut it off there, so if I flip it over, we physically cut the board here and there.
Yeah.
That's the core.
Okay.
Right. So if you want to make a 3G device with some sensing on it, accelerometer, you want to be able to just plug, just actually connect up a solar panel or inductive charge circuit. That's all you need.
Okay, so you can stack it, you can
fold
it.
You can cut it, you can fold it, you can DNP, so not populate certain parts of it, right, to reduce unit cost.
So what could you put on it if you want to go crazy?
Oh, okay. So this board fully populated. It has, in terms of sensors, it has temperature, pressure, humidity. It has gyro, magnetometer, accelerometer. It has a high G accelerometer that goes up to 250 G.
Wow. Okay.
It has light sensor. It has sound level. It has GPS, but 3 flavors of GPS. So with the GPS, you can have GPS low power, so dog tracking application. You can have GPS dead reckoning, so automotive, you're going under a tunnel or into a car park and you want to have dead reckoning. Or GPS high precision, which is a little bit more power hungry, but you can get sub-meter kind of stuff.
Okay.
So you've got a bunch of different sensors. You've got location tracking. You've got 3G, Wi-Fi, Bluetooth, low energy. Then in terms of power supply, you've got inductive charge, solar, 5-volt input for just a normal phone charger. You've got at the end there, you've got USB RS485, which kind of sounds really old school, but awesome for if you've got a monitoring application where you want to run like a longer cable somewhere and you've got a little sensor.
Yep.
And to support that, it's got a SMPS power supply that provides, I think, 700 milliamps at 5 volts. Out so you can have your remote sensor running off that and then communicating. Then you've got SD card at the top. You've got a bunch of memory in the main core, but then there's an SD card at the top if you want to do that. That's more for a base station. And then what you've got is this little expansion connector here, FFC cable. FFC connector where we've got these little boards that go on top. So probably some of the more exciting ones are LoRa. So I don't know if you...
What is LoRa?
Yeah, LoRa's very cool. So for a long time, people have come through our doors and said, listen, I want to make an ultra low power, small, low cost thing to sense something or track something. And if you can have links like a kilometre or so or 2 kilometres with a lot of stuff out there at the moment, but often these applications have longer distances. Imagine a farm application or something where you want to be 10 kilometres away. LoRa is ultra low cost in terms of the actual hardware. You can be talking dollars, right? But I mean often a module might be $10 or so. But ultra low cost, ultra long range. So we're talking there are claims of like the English Channel kind of stuff,
right?
100 kilometers. Yeah. Well, actually, I don't know how long the English Channel, but there are claims, and there's actually I'll get to Sigfox and Tagwell as well, but there are claims of like 100 kilometers for all of these. But that's where you've got like a couple of guys, line to line, big mountains, like on top of 2 big mountains. But in terms of practical cases, in really urban environments, you might be down to 5 Ks or something, but you tend to get 20 or so. So 20 Ks is what.
That's pretty cool.
Yeah, but on a battery with a AA battery, transmitting once an hour, you can be out there for 10 years.
Right. Can I just buy a LoRa base station now? Or?
There are some. They're quite expensive. They're like $5,000, but you could build a LoRa base station for like. Very
No way.
Yeah. This. Well, because what you've got here is you just solder on your LiPo battery. You solder on your solar panel if you want a base station that's going to be charging, and you just clip on the LoRa core, and you've got a LoRa base station right there. Now,
in terms of spectrum.
Yeah, 900 meg 433. Yeah.
Wow. Okay.
Yeah, it's software selectable. But so you've got LoRa. You've also got Sigfox, which the really cool thing about Sigfox is. They're talking about deploying a LoRa network. LoRa networks are being deployed around the world. Yep. Sigfox, they're actually both French companies, I think. But Sigfox have deployed a lot of countries, like they've covered complete countries. And when Sigfox pick a country to cover, they kind of do it within a year. Right. So you've got 2G, 3G, 4G going up the spectrum in terms of bandwidth. But you've also got this kind of step backwards to the narrowband networks. So this also supports Sigfox, so Sigfox LoRa. We've kind of straddled all options with this, as well as Tagwell, which is an Australian company here that have really, really ridiculously long range and low battery life. So this is really cool for applications where, again, if you go back to your dog tracking collar, the problem is you're probably charging it up every 3 days if it's 3G, right? This kind of thing you can put on your dog for 3 years, and not have to worry about charging up anything. We've also got, so on top of those, we've got Bluetooth Low Energy, we've got Wi-Fi, and actually the Wi-Fi and 3G hardware is the same as the Spark Core Photon. It's the same stuff.
So 63,000?
No, that was the old one. The new one is the Broadcom chip.
Okay.
Yeah, so you got, it's actually the same hardware, like the actual SARA U-Blocks module, the STM32, the Broadcom Wi-Fi module.
Mm-hmm.
The Bluetooth that we've used is the same as what's pretty much on nearly all wearables.
Like Nordic.
It's the Nordic one, yeah. And what's cool about that is with a software change, you can just make that into ANT Plus as well for communicating with with personal health devices. Like the bike computers and
all that kind
of stuff. Yeah. What other radios? Oh, we've got an XP, little XP thing you can plug in, so you can take it onto any XP network.
People still using XP?
Well, the great thing about there's like 5 million XPs being sold or something.
5 million.
That's I read that somewhere. So XP is really out there, and a lot of people have devices out there that have XP in them. So we wanted to make an XP. I don't even know what we're going to call things. I guess we can't say Shield, but you know what I'm talking about, like a
daughter board.
Yeah. Yep. But yeah, we've got an XP daughter board for it. I'm just trying to think of other. I think that's pretty much all the wireless connectivity.
So you hook it up to your IoT platform of choice.
Yeah, you can. Yeah, totally. Yeah.
Awesome. Anything else you want to say about this guy? It looks pretty cool.
I think the main thing is just the length is where you want to cut it. So we mechanically cut it in production, and I think the smallest one is 35 mils long. The other cores, of course, get smaller from there. But yeah, you can build a base station. You can build a sensing device. It's just 3G, and when it comes to the form factor, the reason we went with long is because if you want to make something really thin, you can put a battery right next to it.
Yeah.
Right? Okay. That's the same as, say, the iPhone. If you want to make something short and stumpy, you can cut it and then have the battery on top. So if you want something like that looks like a cork. If you wanted a base station, you don't care, you just kind of have the whole length of the thing there. And then what we do is a little bit, it's kind of like the opposite philosophy to Arduino or BeagleBone where you stack things. So what happens there is you've got a base processor and you stack things on top. Once you get rid of, like, our inductive charger, our LiPoly charge management circuitry would probably be, in terms of, it's a 2 millimeter by 3 millimeter chip, so it's kind of nearly fitting within one of the pins. So if you think about how you add a shield for LiPoly charge management, on this we've actually just got BGA's no 201 parts, so that what you do is you just don't populate that if you don't.
So what is a BGA, just for the?
BGA, it's called a ball grid array. You've got a very small chip, and instead of having the legs coming out, they're little balls underneath that then get soldered down onto the board. So you don't even see the pads.
So just tiny.
Really small stuff, right? So this has got some very tiny little micro wires and things to get all of our routing out. But our philosophy is, instead of stacking, it's all about subtraction. It's about saying, well, if you don't need inductive charge, we won't populate that.
Yep.
And that's how what we're doing is we're targeting something that can be really small, so it can be a commercial product from day one. Okay. Right? If you kind of make your dog tracking collar out of this, you know, we're saying that it's quite big, but really, really small. Ultra low power consumption. It's 2 to 3 milliamps. 2 to 3 microamps in sleep. Right. So this thing can last a long time until you, of course, boot up a 3G network.
Yep.
And then in terms of cost, that's a difficult question for this, because if you go with the burger with the works, it's you've got a lot of different stuff in there, but you just pull off what you don't need. And what we did is we made sure that when we're selecting all the parts, that they really are parts that can be in high volume, really low cost.
It's pretty cool.
Yeah, we're really excited about it.
Have you sold any yet, or are you using them out on the wild?
Yeah, we've only got 10, so we're at the moment they're just on benches, spitting out smoke in places. But
so the game plan, you don't mention that, we can edit that out. The game plan is that you do consulting day by day, and people say, I want this widget, I want these features, and you're like, yep, I've got a board for that, we'll just stick it in there.
So we want to get faster at building IT solutions. That's one of the main things for us to use this board. Is we've essentially built the tool or the three cores that we want to use to make us the guys who can just deliver these commercial products really fast. But we're also doing an enclosure range that, like pre-existing enclosures. So if someone wants a base station, they can just grab it, we can program it.
Are you actually making your own?
Yeah, we're doing we're doing 20 different enclosures. Yeah.
That's expensive.
Yeah. I know. We're serious about this. So no, there's about 20 different enclosures. So there's a range of base stations, and I can bring those in another time. But there's a range of base stations. There's some animal tracking devices. There's some devices that go on large assets like trucks or containers. There's some enclosures for, there's a wearable. We've got a wearable. You can make Fitbit out of this if you wanted to. Of course, not that cord, but the smaller one. So the idea, I mean, really, what we want to do is, if you think about it, like Internet of Things is the third generation of computing wave. You've got the computer, you've got your smartphones, and the great thing for software guys is that in those days, or like in those peak times, you've had a couple platforms to worry about. You've had Mac and of course Windows, and you've got only a couple of platforms designed for it. But now with the Internet of Things, 50 billion devices connected by 2020. There's a lot of very different devices that need to be built. A lot of very, very different devices, and they all have their own needs. So you don't have this one hardware platform. You've got a bunch of developers now developing for all these different types of devices. So what we're trying to do is make that easy. So a software developer doesn't have to worry about soldering something, or doesn't have to worry about actually designing some hardware or an enclosure. You can just grab this and you can just go, right, I want the wearables one, or I want the indoor base station, the outdoor base station, and they grab it. They can develop applications. Yeah.
That's pretty cool. As a lazy web developer, being able to just I want this, and place an order with you guys, and boom, my doorstep appears the perfect device. That's pretty cool.
That's our vision.
That's the vision.
That's our vision.
Awesome. What do you wish you knew back in the day when you first started out that you know now?
I wish I had Arduino. Like, I wish I had a lot of the stuff that is available now. I think that I remember being on the school bus in grade 9, reading through a Z80 assembly programming book that was like literally this thick. All I wanted to do was flash an LED. And that was 20 lines of code. I can't remember how much code, but I am really envious, actually, of, this is not answering your question, of what people have today. Like, it's amazing how you can grab something and say, delay 1 second. The amount of work I had to go through to just delay 1 second was huge. So, to try and understand what to do. I think, firstly, the tools that are available are awesome. In terms of advice, I'm going to go with the really corny line here and say, follow what you're passionate about, because when we're looking, like our team of people, we really try and find people who are really passionate about it, because ultimately, if you do find something you're really interested in and you do that as your job, then the old saying that if you love what you do, you never work a day in your life. But I think for electronics and for this kind of world, it's quite true. People are really passionate. It's like actors, or where they actually just love to do what they do. So I think just build things, enjoy it, and then try and find a job or a role that allows you to do that. Because if you can do that, then, apart from the fact that you've always got commercial pressures like deadlines and things that kind of screw up the playfulness to some extent, it's still really cool. I think a lot of people, when they do what they love, they get good at it and they get better and they do well. And so I think So if there are any passionate individuals out there, are you actually hiring? We are hiring, so definitely. We're looking for hardware guys, we're looking for embedded firmware guys, and also app developers. App developers. We're also really we're looking for someone at the moment who can talk to our clients and actually understand. It's more like a solutions architecture role, where you actually try and figure out what they need and actually come up with the system level architecture. So we're actually we're growing, and we're looking for people on all those fronts.
That's pretty cool. Congratulations on the growth. So where can people find out more about LX? Apply for these jobs?
Yeah, sure. So just our website, which is lx-group.com.au.
So if you Google LX, do you go?
If you Google LX or LX Group.
So L is in Lima, X is in X-ray.
Yes.
LX.
And the other thing is, for the cores, what we're doing is we're we're keeping a little mailing list of people who are keeping informed, kind of like as we're progressing. There's nothing really on the website yet. There's not a lot. Like we're kind of I'm behind on the marketing content, but if you go to the Stay Connected tab on the left-hand side, you can kind of just get updates that are kind of on the in the loop of what we're doing. So, yeah.
Awesome. Well, this is Simon Blyth from LX. Thank you for being on our first show.
Thank you for having me. It's awesome. Very cool.
Thanks, mate.
Cheers.